Capillary action is the movement of liquid along a surface of a solid caused by the attraction of molecules of the liquid to the molecules of the solid. Let's simplify. Plants use capillary action to bring water up the roots and stems to the rest of the plant. The molecules of the water, the liquid, are attracted to the molecules of the inside of the stem, the solid. This attraction is used to help force the water up from the ground and disperse it throughout the plant. There are three forces involved with the process of capillary action. Let's discuss them. Adhesion is the process of attaching one thing to another. For plants, adhesion allows for the water to stick to the organic tissues of plants. Cohesion keeps molecules of the same substance together. For plants, cohesion keeps the water molecules together. Surface tension is the effect of intermolecular attraction that causes liquids to form a top or outer layer that behaves like a thin film of sorts. Surface tension is responsible for the shape of water drops and for holding the structures together as plants soak up the water. Although you may use water to help get sticky substances, such as syrup, off your hands, water itself is actually sticky. Water molecules not only stick to each other, but water also sticks to grass, cloth, organic tissues, soil, and paper towels. Plants take advantage of water's stickiness to organic tissues and soil. As mentioned above, capillary action is the movement of the water through the plant. This movement occurs when the adhesion is stronger than the cohesion. Water molecules are naturally attracted to each other. This attraction comes from the temporary hydrogen bonds that they form. So basically, a water molecule has to choose to stay with the other water molecules or go stick itself to the organic tissue of the plant. When the molecule is more attracted to the plant, it is pulled toward the organic tissue. Although the attraction is stronger to the tissue, the water molecule still wants to bring its buddies. Therefore, the first water molecule still attaches itself to the plant tissue, and it also brings along water molecule number 2. Plants need water to grow.
Now we're going to demonstrate field capacity. Now I mentioned to you before that field capacity is when the soil has all the water it can hold under the pull of gravity. Okay, so now we're going to add some water to this sponge, a little bit at a time here. So now we're irrigating. This is what you would do when you were irrigating, only you would want to calculate how much water you need to apply, and you need to understand how much water your irrigation system puts on, etc. Okay? Now, you see that there is no water coming through the sponge. There's no water coming through the soil profile. This sponge is now at field capacity. Now, if I add, just let's say, one more drop of water, water comes through the soil profile and drips down and out the bottom. And if that's past my root zone, the plant physically cannot get that water. And it's going to go into the groundwater, taking whatever nutrients or chemicals, herbicides, pesticides, other things, whatever is in that soil, take it with it into the groundwater and back into the river system. Here in the upper basin of the Colorado River, we are very concerned about salinity and saline return flows into the Colorado River system because of the amount of money and damage that it causes downstream in the Colorado River and on into Mexico. The first definition I'm going to talk about a little bit is called wilting point. And that's where, when the soil's dried out so much that the plant cannot extract enough water to keep its self-turgid, the leaves actively growing, instead they fold down because they cannot keep turgid and upright, then we call that wilting point. It's just too hard for the plant to pull the water out. The other concept that I want us to learn is called field capacity. Each soil, depending on the soil texture and structure, and the amount of organic matter is very important also, will hold a certain amount of water under the pull of gravity. Once you add any more water, that water continues down through the profile and eventually it will enter the groundwater, and the return flows into river systems. At wilting point, there is still moisture in the soil, but the plant cannot get it away from those soil particles, cannot get it inside its root cells and into the plant. No matter how hard it tries, it can't get it in. But it's still a little bit damp. That's wilting point.
The course that MIT is offering with NASA, Boeing, and other partners will
Most people and most businesses can shoot a video like this.